Hello math friends, today's episode is on combining like terms. Yes, combining like terms. First of all, let's talk about what like terms are, the definition. Like terms are terms in an expression that have the same variables all to the same powers. Down here, I have some examples. 3x plus 4. This is an expression. There are two terms in that expression. Neither of those terms are like terms because in order to be like terms, they have to have the same variables all to the same powers. If we look at this next example, we have 1, 2, 3, 4, 5 terms. We have a 2a term and an 8a term. Those are like terms. They can be combined. So 2a and 8a would give us 10a. We have a 5b term and a negative 2b term. Those two terms are like terms. They have the same variable to same power. Those can be combined. 5b and a negative 2b is a positive 3b. And then we have a negative 4 term. There aren't any other constant terms. That's called a constant term because it doesn't have a variable or variables with it. There is no other constant term, so that term has no other like terms. And so we write our simplified expression 10a plus 3b minus 4. Let's take a look at this expression. We have several terms here. 1, 2, 3, 4, 5, 6 terms. But even though we have 6 terms, there are only some of those terms that are like terms. So in order to have another like term to 3ab squared, we'd have to have another ab squared term. So there's one and there's one. Those two are like terms. Just because we have an a and a b and an a and a b in this term, the variables the powers of those variables don't match. Have to have the same variables to the same powers. So here we would have these two as like terms. Then we have an a squared b term and an a squared b term here. So this term and this term are the same, or like terms. And then we have another AB and AB term. So here our like terms are 3AB squared and another 5AB squared. And then we have a 2A squared B term and a negative 6A squared B term. And then we have a negative 3AB and a negative 2AB. So if we are going to simplify this expression and combine like terms, then we need to add the 3AB squared term to the 5AB squared term and get 8AB squared. We need to add the 2a squared b and the negative 6a squared b, and we're going to get a negative 4a squared b. And then we need to add the negative 3ab and the negative 2ab. That gives us a negative 5ab. Let's try these. Let's take a look at the first one here. Let's identify our like terms. I can see down here at the end we have an x squared term. We don't have any other x squared terms in this expression. So I know that when I simplify this, I'm going to write that 3x squared term first. Typically, the powers are written in alphabetical order, with the highest power written first, typically. So I'm putting the 3x squared first. Then I need to see if I have any other x terms. There's the 4x, and here's a negative 6x. So if I add 4x and negative 6x, I get negative 2x. I have a 3y and a 2y, and so 3y and 2y will give us 5y. We have let's see, a negative 5z and a positive 4z. That would be a negative 1z. And we have a negative 2w term here. That kind of snuck in there on me. It really should go right here. So I'm going to write it here, and then I'm going to rewrite this as 3x squared minus 2w. There aren't any other w terms. Then the minus 2x plus 5y minus z. And that's our final simplified expression where we have combined like terms. On this next problem, we have m term n squared and m squared, mn, n squared, m squared, and an n cubed. So I'm going to write that term first. There aren't necessarily always any hard, fast rules to that, but typically the highest power is written first. And then we write the other terms with the variables in alphabetical order. So next is our, we have a 5m squared and a negative 4m squared. And so 5 and negative 4 would give us 1m squared. I like to sort of cross out the terms as I simplify and combine my like terms. So after m squared would be our n squared terms. So I have a negative 4n squared and a positive 2n squared. That gives me negative 2n squared. Then we have a 3m and a 6m. That gives us 9m. And then finally, an n term sitting there by itself. No other terms that are n terms. So nothing to combine that with. Our simplified expression is n cubed plus m squared minus 2n squared plus 9nm minus 7n. Getting a little tongue-tied there. Okay, let's look at this one. This one here is a little bit more complicated. We've got three variables, D, E, and F, but we need to make sure that we have terms that have the same variables with the same powers. So I'm going to take a look. I've got a D squared EF term there, a D squared EF term here, a D squared EF term here, and that's it. So if I have 1 D squared EF and negative 4 D squared EF and a negative 2 D squared EF, that's going to give me, let's see, we've got negative 6 and a positive 1 is going to be negative 5 D squared EF. Then we have a D, let's cross these out so we make sure that we have used them. Then we have a D E squared F, and here's another D E squared F and another D E squared F. So I have a 1 D E squared F, negative 8 and positive 7. Well, the negative 8 and the positive 7 is going to give me a negative 1. The negative 1 and the positive 1 are going to add up to 0, so those terms completely add out. Then we have a DEF squared term. Here's another DEF squared term. And here's another DEF squared term. So I've got a negative 5, a positive 6, which is a positive 1, and a negative 4, which would give me a negative 3 DEF squared term. Mark those off so that I know that I've used them. And then finally we have this one term left over. Does not have any terms that are like it. No other DEF terms. So I have a positive 5 DEF. So that entire expression, even though the variables were the same, the powers were not. And so I had to make sure that I found the terms that were like terms, that is, terms that had the same variables and the same powers in order to combine them. Let's take a look at this last one here. I've got an xy cubed z. Let's see if I've got another xy cubed z. I do not. So I'm going to go ahead and write that one. Then I have an x squared y cubed z. I do not have any other x squared y cubed z terms. I have an x y squared z. Here's an x y squared z, so I have this one. And this one, a positive 1 and a positive 11 is a positive 12 x y squared z. And then finally an x squared y squared z. Very close. Have to be very careful. But there are no other x squared y squared z terms. So that term is by itself. Nothing to combine it with. So that entire expression simplified to the 7xy cubed z plus 4x squared y cubed z plus 12x y squared z minus 8x squared y squared z. So remember, combining like terms have to have same variables, and they have to be to the same powers. If you don't have those two conditions, you don't have like terms. Well, that wraps it up. Thank you again. If you like this video, give it a good thumbs up. If you want to see more videos, subscribe to the channel. And if you want to be notified when videos are posted, click the bell. Until next time, see you on the next episode.